So 5.7 is where we're starting, okay? Graphing exponentials first, okay? You'll notice this equation. What do you see about this? That looks very, very familiar. H and K. H is my bad friend, right? He's the opposite of what he says he is. If he's positive, that means move left. And if he's negative, we move right. Okay, and then K's my good friend. If he's positive, we move up. And if he's negative, we move down. Okay, all of these blanks then, all of that stuff. If A's negative, we reflect. If A's bigger than 1, vertical stretch, less than 1, vertical shrink. I'm not going to rewrite all that stuff out because it's the same as what it's always been, and I'm going to save us some time today. Okay, asymptotes. What are asymptotes? What are they? What are they?
The measurements of how far X and Y go.
You're not too far off. We made them dashed lines, if you remember. They're going to be dashed lines / invisible lines that the graph gets close to. But doesn't touch it or doesn't cross it. That's what an asymptote is. So we talked about these when we talked about our rationals, okay, or our fractions. So it's just a line that the graph's going to get really, really close to, but it doesn't cross it, okay? So what we need to know about this is that exponentials, that's what we're dealing with right now, have horizontal asymptotes. I'm going to write this really big and then at the bottom, and I'm going to circle it, and I'm going to highlight it, and I'm going to make sure we know that because that's important, okay? All exponentials are going to have horizontal asymptote, just one, okay? Where's that at? It's always at the K value, which is just the value at the end, but honestly, when we type these into Desmos, it's going to make it really easy for me to just know that, okay? Same thing with domain and range. These are going to really click once we start doing these, okay? So we're going to go to the next page. Here it is. And this is my first graph that I am typing into Desmos. So go to your Desmos app on your iPad. If you don't have an iPad, use one of these desktop computers. If you don't want to do that, use your phone. It'll work on there too. Okay, go to the app or to desmos.com, and you are just typing in 3 to the x power. If you need help doing that, raise your hand and let me know. So I'm going to go put a point at 0, 1, because once again, that was a point Desmos gave me. Give me another point that Desmos gives me. What else? What else? It could be a decimal. It could be a whole point. What do you got? What'd you say? Go to the right a little bit. Like up here. Like what does this give me? Give me something. What? What'd you say?
It's like 1.465.
1.465? Or 6.5, you mean? Look right there. Okay. Okay, so just as long as you have enough points on here to where you realize what's going on, okay? So I'd get 2 or 3 points on there, and then we need the asymptote, okay? So that's where we have to go to Desmos, and once again, we already know exponentials are going to have a horizontal asymptote, okay? So I need to look for the horizontal line that this thing is approaching but not crossing. So once again, it's getting really, really close to 0, but it's not crossing 0. So I'm going to put a dashed line at 0, and then I'm going to connect my points here. Once again, just make sure your graph doesn't cross the asymptote. It just gets really darn close to it, okay? And that's it. That's all you need for the graph. After that, you're just answering the questions, okay, which should be pretty straightforward. So first, let's talk about domain. What is domain? It's x from the left to the Right, okay, so what is this thing doing as far as going to the left? It's going to negative infinity, and what's it doing to the right? Positive infinity. Guess what? That's the domain for every exponential. Negative infinity, positive infinity. Okay, what about range though? This is y values, and we start at the bottom and go to the top. Okay, so where's this starting? It's starting at the asymptote. It's always going to start at the asymptote. So in this case, it's at 0. Can it equal 0 though? So should I use a parenthesis or a bracket? Think back. Parenthesis. Parenthesis means it can't equal 0. Bracket means it can. Okay, so use a parenthesis. And then where's this going to the top? Infinity. Perfect. So that's your range. Asymptote to infinity. It's always going to be what that is. That is always going to be it, okay, unless it's reflected over that line, which we won't see a whole lot in this class, okay? The asymptote, we already talked about this. Where is it? 0. Y or x equals 0? Y, good. Okay, there is no vertical one. Never will be for an exponential, okay? Then we have our end behaviors. We always, always, always copy the what values for the x's right here. The domain, good, okay, so we're going to do that. In this case, it's negative infinity and positive infinity. Okay, so now I'm just asking myself, the left end, so x is going left forever. What's y doing? Isn't it just kind of staying at 0? Yeah, because it can't cross 0. Okay, and then the right end, so as x goes right, what's y doing? Up. Positive infinity, okay? These y values right there for the ends, do you notice how they're the same as the range? They'll always be the same values, but sometimes they might be flipped, okay? The domain values will never be flipped. The range values might, just depending on what your graph looks like, okay? When we think of intervals, we think of a roller coaster. If this was a roller coaster moving from the left to the right, what would it be doing? Increasing the whole time, right? So we always copy the domain. Every single time we copy domain. You don't ever copy range for the intervals, increasing or decreasing. Okay? It's not decreasing, so I put NA there. And then once again, we're using Desmos. So these intercepts, I don't have to do any math. Okay? I just go look at the axis. Where am I crossing the x-axis? The x-axis. Am I ever touching it? No. That was a trick question. And then what about the y-axis? Write it as a coordinate point. 0, 1. Perfect. Perfect, perfect. Okay. That's it there. That is it there. What questions do you have? Okay. You ready to do another one? Sure. Okay, so your homework is actually going to be directly off these notes. We're just going to star those problems, and you'll come back to them when we're done with notes, okay? Your first homework problem is going to be number 2, so we're going to skip that one for right now. I don't really want to do either of these problems, so we're going to skip 3 and 4. We're going to do number 6 right now, but 5 and 7 on the next page are going to be your final 2 homework problems for this section, okay? So 3 homework problems total for exponentials, but number 6 is the one we're going to do right now together, okay? So I want you to go type this right here into Desmos. Exactly how it's written. This one's a little trickier to type in, which is why I picked this one to do together, okay? So go type this in exactly how it's written. One little thing that might help you too is that when you go to type in the power here, you might have to put that in parentheses just because some of the Desmos apps weren't letting people type it in without the parentheses. So try that out. Okay, what points? 0, 10. Okay, that's kind of up here. What else? 5, 2.25. Okay, what about the asymptote? Where's that?
10, 0, or 0, 10.
the asymptote. So the line that it is, we already got 0, 10 on there. The asymptote is going to be that horizontal line that it's getting really close to but not crossing. If we look at it.
17.
Anybody find the asymptote? So it's just a horizontal line.
No, it's just 2.
Okay, it's going through 2. Perfect. Which is the K value, so that makes sense. Okay, so here's my graph. I got some points on it. Once again, just make sure that when you go to draw this in that you don't cross your asymptote. You just get close to it. Okay, you don't have to be the most perfect artist in the world. Just as long as I can see that that is the general shape that this graph looks like and it's in the right place. Okay, the domain here is going to be what? Negative infinity, positive infinity. Good. What about the range? 2 to infinity. Good. Asymptote to infinity. Okay, it's starting at the asymptote and going up forever. The asymptote is where? 2, and it is
X.
not x. Y equals 2. Yep. Horizontal is always y equals. So I don't have a vertical asymptote. For my x's on my end behaviors, I need to copy my domain, so I'll do that. And the y's, what is the left end doing? The left end of this.
Going up.
It's going up. Okay, so that would be positive infinity. And what's the right end doing? Yeah, it's stopping at 2. Okay, it can't cross 2. So once again, those are my range values. This time my range values were flipped. Do you notice that? Okay, you just have to pay attention to that to see if they're going to be in order or flipped. What about interval? The whole thing is decreasing, right? If that was a roller coaster moving from left to right, it'd be decreasing. So I copy the domain. And then x and y intercept. What's my x-intercept? I don't have one, do I? It's never going to cross it. And then what about y? 0, 10. Perfect. That's it there. That's it there. That's all you're expected to do. If you can do that, you will be successful on this test. Okay? So, for this section, 3 problems, 2, 5, and 7. This one right here. Okay, that's what I need on Canvas. Now we're hopping into 5 points, I think it's 5.9, 5.8, 5.8, okay? And once again, we're not going to do all of these. We're just going to go through a couple, okay? You'll notice, like here, this starts with the T-chart. Once again, we're not graphing these by hand, so I'm not going to do this with you, okay? I'm just going to show you how to use Desmos to get this graph and then tell information about it, okay? So, we're going to start with just this graph right here. It says y equals log base 2 of x. Okay, we're just going to graph that. We're not even going to do the information. We're just going to graph that for this first one. Okay, notice here, what is the base on that? It's written, right? So it's 2. Okay, it's 2 because it says it's 2. So when you go on to Desmos, I want you to go there. Okay. Go over to your functions button and hit that. And then you're going to scroll down to the section titled calculus. We're obviously not in calculus, but for some reason that's just where Desmos puts these functions. Okay. And then there's going to be 3 different buttons to pick from. Okay. There's going to be one that says log base A. That's the one you want to pick. Okay. Because that's actually just going to let you go ahead and type this thing in with the base of 2. Okay, so that's going to make your life easy. You don't have to go change a base formula on this, which is what we had to do when we use the regular calculators. Okay, so that's going to be the button you pick. There's also a button that just says log. Just know that that's if you have an invisible base of 10, you could use that one. Okay, because you don't have to write the base in. And then the last one would be the natural log button. Okay, this is obviously not a natural log, so don't use that one, but if it was, and we are going to see that today, you would use the natural log button. Okay, so those are the only 3 buttons you would use for this section. Are we good with that? Okay, so let's go type in this, and once again, we're going to use this button right here. It's under calculus, so let's go look at that. 1, 0 is on there. That's an easy one. What else? It could be a decimal. It doesn't have to be a whole number. What else do we got? Can't hear. 1, 2. 4, 2. Sorry. Okay, perfect. All right, that should be good enough. Now I need my asymptote, and here's the deal, okay? This is what I need you to write somewhere big where you'll see it. Logs have vertical asymptotes. Exponentials had what? Horizontal, but logs have vertical. Logs have vertical. Just have to remember that. Commit that to memory. Okay, logs have vertical asymptotes. So, thinking about that, we know what a vertical line looks like. Do you see where the vertical line is that this is getting really, really close to on Desmos, but it's not crossing? 0. It is at 0, okay? And you can drag your finger up and down on that line and see, or sorry, in this case, you drag it down, and you can see that those values, actually you hit undefined at 0. Okay, so it kind of just gives it to you there. That's how we do that, okay? Why do you think that this thing doesn't go negative? Why does it not go over to those negative x values? This kind of goes back to the solving. What happened if we plugged something in and got a negative a value? It didn't exist, right? It became extraneous, okay? We can't have negative logs. That's why. We just can't have it. Can't have negative a values. They are extraneous, okay? All right, moving right along. Let's just go ahead and do this one. Quickly, go type this in. And then I want you, knowing what you know about those blanks, okay, and knowing that this one's the inverse of exponential like we just did, go try to fill those blanks out the best you can. I'm going to give you like 2-3 minutes here, okay? So go type that in, graph it, and try to fill those in. Okay, give me some points on this. What you got? 1, 0. What else? Five 1.4. Okay. And then what about the asymptote here? What do we think the asymptote is? Zero. Good, Ava. Cool. It's 0 again. Okay. It won't always be 0. Just happens to be that these two examples that we've done now have both been zeros. But that is 5 negative 1.4. So I have the wrong graph. Okay. Thank you for fixing it. So it looks like this instead. Okay, there we go. Asymptote's still at 0 though, right? Vertical or horizontal? Vertical, so is that x or y equals x? Good. Okay. The domain, what is that going to be, you think, from left to right? Is this going left forever? Yeah, it's starting at the asymptote, right? Okay, so that in this case is 0. And it is going to the right forever, isn't it? Okay, so this looks a lot like my range did on exponentials, right? Yeah? What do you think the range is going to be here? Bottom to top. Is this going down forever? Yeah, it is. Is it going up forever? Yes, it is. Okay, and that looks a lot like my domain from exponentials, right? So doesn't it make sense that these are inverses and their domain and range are polar opposites? Because that's what inverse means, is opposites. Are you with me? Are you with me? Are you with me? Okay. If I took my iPad and I just rotated this, doesn't that look like an exponential, which is what we just graphed? Now it's a log because it's an inverse. You with me? That's what we need to be grasping here, okay? So that is how this works. Rest of the blanks. End behaviors. I always copy what for the x's? The domain values. So in this case, 0 and infinity are my domain. Okay, and then the y values. The left y value. So as x goes to 0, y is going, just look at the end. What's this arrow doing? It's going up forever. What is that? Positive infinity. Okay, what is the right arrow doing? It's going up or down? Down. Negative infinity. Notice how those are the range values. They are flipped. Sometimes they won't be flipped. You have to pay attention to that. Okay? If this was a roller coaster moving from left to right, what would it be doing? Going down. So that means decreasing. And I always copy the domain. The x-intercept. Where do I cross the x-axis? 1, 0. Where do I cross the y-axis? Never. Good. How are we feeling? Is this clicking a little better? A lot of us look really zoned out, which is unfortunate. You need to lock in. Okay, we got to understand this stuff. What questions do you have? Be grateful that you don't have to do this by hand and that you have access to Desmos because it is a lifesaver on these problems. Okay, it makes the rest of this really straightforward. So if you're still missing it, I don't know. Got to get help, okay? All right, so I'm going to give you 3 homework problems here. We're still going to do one more in the notes, but your first homework problem, we're going to skip that. Your first homework problem is going to be, we're going to skip this page too. I don't want to do those. These 2 are homework. Okay, so this page, it's got log base 4 of x minus 1 plus 2 and 4 log 2 of x minus 3. Those are homework. And then this natural log right here is going to be homework, but this one right above it, that's just y equals natural log of x, that's a parent function. We're going to do that one real quick, okay, because we do need to know what that looks like. We haven't done a natural log. We just did 2 logs, okay, 2 regular logs. So let's quickly go do this one together, okay? Once again, use the natural log button. It's under calculus. So go type this in. Go put it on the graph. Hurry, 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 hurry. Okay, points. Give me some points on this. One zero's on there again. It's not always going to be on all these graphs, okay? It just happens to have been on all the examples that we've done today. What else? Repeat that for what? 1.386, okay? So that'll be right about there. Perfect. And then the asymptote is going to be where? It's 0 again. Will it always be 0? No, it won't. Promise it won't. Okay, but sometimes it is if there's no k value. Okay, so there is that graph. Once again, I'm not an artist. Just a sketch. Beautiful, beautiful. The domain on this, left to right. Nope, left to right. 0. Infinity, good. Parentheses on both. Range. Yep, that one is negative infinity, positive infinity, good. The asymptote is where? Vertical at 0. So that's x equals 0, right? For the x's on my end behaviors, I copy my domain. And as x goes to 0, what's that left side doing? Y goes negative infinity. That arrow is going down. And then what about the right arrow? Is it going up or down? Up. What type of roller coaster? And copy the domain, always the domain. And then my intercepts. Do I have a y-intercept? No, because the asymptote's there, but what about x? 1, 0 again. Okay, so that one was pretty simple. It was a lot like the one we've already seen before, okay? But make sure we know that stuff. Make sure we do those 3 homework problems. So in total, we have 6 problems today that I want submitted to Canvas, okay? First 3 were in the exponential section. Last 3 are in logs. What questions do you have? Are we okay with this? Okay, it's not a free day, so don't you dare just get your phone out and get on TikTok. We're not doing that, okay? But get to work on these, get these submitted. You have plenty of time. You shouldn't have homework tonight.